Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm over here at my Monarch 28-inch lathe, and today I am going to get started on trying to see if I can fix something that will let me use it on this lathe, because as seems to be the case more often than not around here, what ends up causing me to fix my stuff that's broken or has issues is the need to use it on a project. And it pretty much forces me to get my tail in gear and do what I need to do. With this big Monarch 28-inch lathe, I acquired this lathe right about the time I built the shop. In fact, it was one of the first machines I brought into the shop. Picked it up from a gentleman over in Alabama who unfortunately had passed away, and through a friend of his, I was able to get this lathe. I was told when I bought it that the lathe was in great shape, that it performed very well. It was an extremely accurate machine, and I brought it into my shop, did a cosmetic restoration on it, basically just cleaned it up, repainted it, did a few little things, just fixed a few little issues that I've had with the lathe along the way. Many of those you guys have probably seen in videos over the years. And I have started using this lathe, and it indeed has proven to be a pretty accurate machine. Still has a few issues on some things that I would like to work out eventually, but it is a good, usable machine all the way around. Shortly after I got this machine in the shop, I picked up a steady rest that supposedly fits it. And guys, I don't even remember exactly where this came from. I think that a gentleman up north had it as part of a machine. I got several parts from a very similar Monarch lathe, including a tailstock, some parts for a tailstock, because I was missing that when I got this. Already gone through and got all that taken care of off of parts of other machines. Seems like I remember it came from up there. That may not be right. It has been a long time. But I've got a steady rest that's supposed to work on this machine, if I remember correctly, but it's broken. Really what's kind of gotten me into doing this project today is that I started another project over on my 16-inch Monarch. And when I started that video, I said I really wish that I could use the big Monarch because this part's going to be a little bit limiting factors, whatever. But I didn't have the steady rest ready to go, so I was just going to try to get done over there on the 16-inch Monarch. For various reasons, and when that video posts, you can see why. I basically said, you know what, I need to just get this steady rest fixed over here where I can use it. So that project's on hold. We'll probably continue on it with it later on in another video once we get this done. But today, I want to get this steady rest over here. First off, I want to get it up on the machine and just make sure that it is right, that it fits, that it's going to work, it's the right size. I seem to recall that I've done that already, and then come up with a game plan on getting it fixed so that we can get to work. It's on this pallet. I've got some rotary tables. There's a shaper head that goes on my K&T milling machine, and then I got the steady rest on here. There's some other stuff. It's just some miscellaneous parts I got on this pallet. So I've got the jib crane here. I'm going to go ahead and get this picked up, put over here on the lathe, and we're going to start taking a look at it and see what we can do and see if this can be a good project for us to get fixed up so that we can use it going forward. So I got this picked up over here with the jib crane, and we're just going to take it right in here, drop it right down on the lathes. I believe this is going to work. Like I said, I thought I had kind of done this little step right here before, but it's been a while and I just didn't remember. So let me get the camera moved. I'm going to bring you over here. We'll show you what we got and show you what we got to do to fix it. All right, so I've got this on here, and yeah, all looks good. It fits just fine. The height is the correct height. And it's coming back to me now. I seem to recall that I picked this up from a guy up in Michigan several years ago that I also got the tailstock from. This came off of a lathe that was basically one model newer than the one I've got. It was the same size machine, very similar machine, but they did make some changes between the two models. And one of the things that they did was that they made the bed about a ½ inch narrower, maybe an inch narrower, well, about a ½ inch, maybe 3/4, something narrower. So if you look down here on the bottom, this does not come out all the way to the edge. It's only hanging the same way my tailstock is. But the center is still lined up on the center. So from the back side, it's the same. They just kind of moved one of the ways in a little bit. And it works. It works just fine. Now, if I remember right, the clamp on the bottom is also a little bit too narrow, but I've actually got some castings that I had done that are the clamps. I made some steel ones for the tailstock, but I also had some cast iron ones cast, and I need to get those machined and replaced and put on there. But when I did it, I cast one for this too because I knew I was going to need one later on down the road. So I've got that piece to go in there to fix that. What is wrong with this, I've got the top part, but if you look right here, this is the hinge where the top piece just kind of hinges on, and it's snapped off. It's broken. And I don't believe that I've got the piece that broke out of there. It looks like it had been brazed back in there at some point in time, but the braze job was questionable, didn't do a good job, and well, you know, actually it looks like it broke on the iron and not on the braze. But anyway, somebody tried to repair it and it didn't take. So we've got to fix this piece down here, which is, again, it's just a piece of metal that has a hole drilled through it that is just a pin that this pivots on, and the top part comes around and clamps, and you can basically open the top up. But now that I've kind of taken a look at everything, yep, I think we're ready to see about fixing it. And this is bringing back my memories of, you know, what we needed to do to it and all that. So I'm going to take this over to my welding bench and come up with a game plan. Let me leave you in here and just kind of show you this a little bit better. So again, this little ear had a piece that came up above it that just rotated on. Instead of trying to braze it across the hole, what I'm kind of inclined to do is cut this off down below it, where I can get a braze that's that entire width rather than two little short pieces, and just drill a new hole in there once I do. I'll come up with a plan once I get over there and get things laid out a little bit better, but that's what I'm kind of inclined right now to do, is that. So let me get this off of here and over at the welding table, and we'll come up with a better plan and go from there. I've got this over at my welding bench now, and I'm going to go ahead and I think I'm going to take this roller out first just to kind of get it out of the way. It unbolts on this side. It's got a stud in there, and then on the other side, looks like there's a couple of cap screws kind of holding that back piece in, and then this whole thing should pop out. Let me go grab my Hex wrenches and we'll get that out. Word. That is in there. Both of those are. Try this with my impact driver. Sometimes that'll break these things loose pretty good. Maybe not. Okay. Plan C. So I've got my impact wrench now. This puts a lot more torque on it. I'm a little reluctant to do this, guys, because this is a 1/2 inch drive. This is a 1/4 inch drive socket. I am over exceeding what this socket is designed for, but we're going to try to get it. Something's going to give here, or maybe it won't. Let's see what happens. Got that one out. All right, success, and nothing broke this time. All right, that is out of there. maybe some dowels or something holding it straight in the back. See if I can get a pry bar in there. It's just tight. And that is out of there. Good deal. So this is the piece that kind of fits down on it, and you can see it hinges right there. And the broken pieces in this is still all together, so I'm going to get that broken piece out just so I can kind of see exactly what it's supposed to look like. So let's work on getting it out. So if you look down here, that broken piece is in there. So I've got this piece up in the vise. There's a pin that goes through this. I don't know if I can drive that out or not. Yeah. And there that piece is, in all its broken glory. Now we got an idea of what we need to replicate. There is the broken part of this all back together. It looks like there's a set screw that was in there. You can see the part of the set screw up here that I guess that keeps that pin in place where it pivots on the outside part, but that holds it in place. And of course where that hole was through there, that just made it all that much weaker through there. So again, I think that instead of just trying to braze this back on and re-drilling that hole, I think instead I'll be better off to kind of cut this thing out down below it. Maybe something kind of like that. Braze in a new piece in the bottom, and that way we've got a lot more contact area for our brazed area without being right through the middle of the hole, which should make it for a stronger repair. So let me figure out, I need to figure out how to place that hole back in the right place. So I'm going to probably put some marks on here to mark the center line, and then figure up where the center is off the bottom of that or something so that I can put that hole back in this right place, and then we'll figure out a way to get that old piece of cast iron cut out of there so that we can make a new piece to go in its place. So I've got the center of this hole kind of marked, and what I want to do is I'm going to put a witness mark, a couple of witness marks in here, just kind of marking that center. I'm just going to put a center punch in there and a center punch there. That way, once I cut this out, I can kind of tell where the center of that hole should be in that direction. And then I need to figure out about where the center is, probably from that bottom down there, so that we can put it back where it needs to be, 1.25 inches. Also want to see how thick this is. Okay, that is 7/8, 875 thousandths. I need to see if I've got a piece of cast iron that I can machine that out of, the replacement part to go in there. I do want to put cast iron. This base is cast iron. Generally speaking, I don't like welding, brazing, whatever, cast iron to steel. You can braze cast iron to steel, but it's not a good idea. And the main reason is that the expansion rate of cast iron is different than the expansion rate of steel. So as this thing just heats up and cools down, even in the shop under normal temperatures or whatever, because those ratios are different, as it does, it's going to be moving it back and forth, and eventually that can cause a weld or a braze out job like this to break out just from inconsistent expanding of the two different materials. So if you make it out of the same material, it's less likely for that to happen. Is it a huge deal? Yeah, probably not, but it's better to do it out of the same material. And some people would argue, well, you don't want to put cast iron back there. It's not as strong. It's going to break easier. Cast iron, yes, is more brittle, but it's actually very strong material. And we're going to put cast iron back in here. So let me see if I can find a chunk of cast iron that we can make that out of. If not, I may have to order a piece of Durabar to make our blank out of. All right, here's what I think I'm going to do. I'm going to go take this and lay it down on my do-all bandsaw and just see if I can just nibble that out with the bandsaw. It doesn't have to be milled perfectly flat. We're going to be grinding and cutting a piece to fit in there and then brazing it in place. I just need to get it out of there, get a chunk out of there. And I put some rough lines in there just to kind of give me a guide to work off of. All right, I'm over here at the do-all bandsaw, and we're gonna see if we can nibble that little piece out. All right, that's got that side cut out. I got this rolling cart here with a surface plate on top. That's heavy duty. This casting, while it's a little bit lighter than it was when I put up here, it's heavy. I can just put it on here and roll it back to my table. Let me get it down there though. Oh, that's heavy. All right, back to the welding table. All right, we got our piece notched out of there. So now we just gotta make a new piece to go back in there. I've got some grinding I need to do to this. We need to bevel these out so they'll be ready for brazing a new piece back in. And I need to order some material and make a new piece to go in there, but I think this is gonna be just fine. I think it's gonna work just like it needs to. So I haven't done really anything else to this except wait for my piece of metal to show up. So this is a piece of cast iron, what they call Durabar, which is basically an extruded cast iron product. You can get it in plate like this, you can get it in tubes, you can get it in bar, different configurations, and it's great, you know, for making cast iron parts without actually having to make a casting to get it. So this is pretty much the same thickness as what we had before. I think it's 7/8 inch thick. May have to do a little bit of work to the width of it, but what I'm going to do is I am going to cut me out a piece to fit down in here. This is the size and everything we need, and then we'll do some weld prep to it and braze the bottom of this in and get it put in. But I think I'm going to go ahead and cut out the profile. Probably going to go ahead and drill the hole in it. While we got it out, it'll be easier to do that here, and then we'll just drop it in there and braze it in place. So let me lay out what we need, and we'll go over to the bandsaw and get it cut out. So here's what I need to cut out. I think I'm going to start by drilling the hole. We need a 3/4 inch hole through there. I'm going to drill that first, and then I'm going to go to the bandsaw and just kind of rough that out. And then we'll probably go here and start doing some grinding to make it all fit. So let's go get her done. Over at my drill press, we're going to start. We'll just put a 3/8 inch hole in here to kind of get it going, and then we'll drill that up to 3/4. Just going to a big pair of channel lock pliers to hold this, give me a little more leverage. And if it strips free, it ain't gonna tear my hand up going around and around in a circle. There we go. I'll get it. Use this tool here to kind of hold my work while I'm cutting it. This is exactly what it's designed for, is kind of to give you something to hold this while you're doing it, so you don't have to get your hands so close to the blade. I picked this up at the Field of Tools tool thing a couple of weeks ago, and this is actually made by Do-All. It's an accessory for this saw. Mare braid sander here. This has quickly become one of my favorite and most used tools in the shop. I love this belt sander. I probably ought to change out, put a little bit coarser blade on here, but I'm gonna be lazy. So I did some grinding in here, put some bevels in, just made it flat across the bottom, and we've got our piece. Again, it's been also kind of ground on and got the bevels and so forth, and that is ready to kind of drop into place here. Yeah, let's go this way, and I think we're ready to braze this in. I want to kind of get it positioned and lined here up in the center, and yeah, let me think about how I'm gonna kind of hold this in place to get it started. I may just kind of heat it up right here and braze it, just kind of get it tacked in on the sides and then flip it over on its side and start working on it. Or I may see if I can get a piece of something put behind it to just kind of get it lined up right. Let me play around with that, come up with a game plan on it, but this is pretty much ready to start brazing into place. I should also mention that I checked it out down here to make sure that that was going to fit in there and pivot. It was actually just a little bit too thick, so I had to take it back to the grinder and do a little bit more grinding on it, but no big deal. We got that knocked out. That's going to pivot very nicely in there. All right, let's see if we can get it braced in. All right, we're going to start by putting some heat into this part, and I'm going to do that using this rosebud tip on this torch. This is just a pretty good sized flame, and I just need to get this heated up, kind of preheated, before we really start trying to focus some heat in a small area for brazing. So we're just going to kind of heat this up. The part is going to act like a heat sink, so I want to kind of not just focus up here, but kind of focus all around and get some heat kind of uniformly put in here. There is some grease and stuff down below. It'll burn off. The top part where I'm brazing that, though, is pretty darn clean. Now, you guys that watch my channel all the time, you know the spill that's about to come, but I do this every time because I get new viewers who may not have seen this before or heard it before. Why am I brazing this instead of welding it? Well, guys, the bottom line is that in my opinion, brazing is a much better option for repairs on cast iron. We're dealing with cast iron here. We're not dealing with steel. You got a steel? Yeah, just weld it. This aluminum? Yeah, just weld it. Welding is where you melt the base material, put a filler rod in there, usually of the same material, and it's all bonded together nicely. Why do we not do that with cast iron? Well, with cast iron, it's difficult to actually melt the material because of the way the cast iron is. You can, but when you do, you actually change the structure of the iron, and it melts and comes back together. And when that happens, it becomes very brittle. So with brazing, instead of actually melting the base materials together and using a filler rod of the same material, we're going to use a dissimilar material to bond them together. In this case, we're using the brazing rod, which is a brass or bronze. Really, it's a bronze alloy. But we're going to be using that to actually fill it in. We don't melt the base material. We melt the filler, and the bronze actually does a very good job of binding with that cast iron. It's actually a very strong joint if brazed properly. The brazed area is just as strong as the cast iron, so it is a very good repair method. I work restoring old machinery all the time, and it's not uncommon to see old brazed repair jobs. In the vast majority of the cases, they hold up to the test of time. And usually when I see one that has failed, it did not fail along the brazed joint. It actually broke into cast iron again. That's the problem I see also with welded cast iron. You can weld cast iron. You can use a nickel rod. There's some different materials out there, and there's some people that do it quite well. But typically when I see those, you'll see them fail, or when you see them fail, you'll see the cast iron crack right at the edge of where the nickel and the cast iron come together. Again, when you melt that base material, you're making a structural change to the cast iron. It makes it very weak and brittle, and it's very likely to break along that joint. With brazing, yes, it can still happen, but it's actually much less likely to happen than it is with welding. So there you go. If you disagree with me, that's fine. I'm not going to say you can't weld cast iron. People do it all the time. But if you do weld cast iron, you got to really know what you're doing. And even then, I personally just feel like brazing is a better option. All right, I've got a little bit of red starting to show up on all my parts here, so I've probably got enough preheat in here. I'm going to change over to a brazing tip, which will concentrate my heat in a smaller area, and we'll start actually brazing this material together. So let me do that real quick. All right, I got a brazing tip now, smaller tip, but we're going to be focusing our heat in the area that we're working. And right now, I kind of want to get this tacked into place on the sides, and then probably lay it down flat to do the bottom part. But I want to kind of get it held in place first. There is a little bit of braze left over from the previous repair that's probably going to melt out. That's fine. But I want to get this a little bit more of a red before we start getting it in there. I'm very close to temperature though right now. I'm using a brazing rod again. This brazing rod that I'm using is pre-flux. It has flux on it. That flux basically helps to keep the oxygen away from there so you don't get oxidation. You get a better weld. You can take a raw rod and just kind of dip it into flux as well. This one has the flux kind of pre-applied on the rod. I use both just depending on what I've got. So we're about at temperature here, so I'm going to, sorry guys, I realize I'm probably right in the way of the camera there. I don't know how much of this you're going to be able to see anyway, but I'll just kind of introduce my rod down in there, and we'll start kind of laying that braze in. And we just kind of want it to flow into place. It's not quite doing that yet, so I probably need to get a little more heat in there. But now that I got a little braze in there, I can kind of see it when it just kind of, it'll usually just kind of drop in there and flow into place. And when that happens, you're typically at the temperature. I just saw that happen. It just kind of just dropped down in there. Probably didn't see it on the video, but you just have to trust me. But that is bonded well. And again, I'm just kind of hitting these sides right now just to kind of hold it in place, and I'm going to lay it over. All right, that side's done. Then we'll come over to this side. Give me just a minute to get some preheat in here, and we'll do the same thing. And again, kind of just melt a little bit of braze down in that gap, and it does seem to be bonding. Got a little bit bigger gap here to fill in than I did on the other side, which is fine. All right, we got our sides kind of tacked into place. I'm going to reposition my work, lay this down flat. It's easier to braze flat than it is up and down. Your material doesn't want to run out all over the place, so we'll get set up and finish this up. Start filling in that gap with braze. And make sure it flows down in there good. I don't want to just melt it in there. I want to make sure it's flowing good. I know you guys can't see much in my screen, and I know there are people out there that make welding videos that have filters and stuff for their cameras to do this. I just don't do enough of it to spend the money to invest in all that equipment, nor do I really have the time to play around with it and get it all done. My channel's not so much about welding and brazing as it is about machinery repair and machine shop work, but you got to do some of it. All right, that side's done. I'm going to flip this over now, and we'll get the other side done as well. Well, it is actually still the same day. This has cooled down. I can touch it, but it's warm. And I just wanted to kind of check things out here. So first off, I did take the grinder with a flap disc and just cleaned it up a little bit. You know, looks like a pretty good braze job around there. I could have raised that up a little bit higher where I would have had to ground it off to make it flush, but I chose not to, just because there's some pitting in there. That's just barely below the surface. That's just really the contours of not filling it all in. And I chose not to fill it all in just because, again, I didn't want to have to grind a bunch out. But we got a nice secure tab here. I did take a 3/4 inch reamer and run through this and just clean that up to make sure it's the size. I did the same thing on the piece that it connects to, and cleaned the pin up that goes in here. The pin does slide in just fine. Now, on the original, there was a tapped hole through here with a set screw that tightens up against this pin, and basically it locks it in the center so that the pin does not move and the body rotates on the outside of it. So I'm going to get a hand drill and do the same thing. We're just going to drill and tap a hole in there, and we'll be ready to put this thing together and test it out, make sure everything fits like it should. Let's give it a shot here. So I have put a coat of paint on this, and we let that sit overnight. Still just a little bit on the tacky side, but not bad enough I think it's going to hurt anything. I do want to go ahead and kind of get it put together here. This pin driven in. Tighten my set screw back up in there. And here we go. There we go. This is the actual part. I've got these cleaned up. That slides up and down in there. I've got the adjuster here on the back that will screw in. I'm going to go ahead and kind of get that started. Slip those in place. Screw this down, and there is a bolt that goes across the back that will tighten this up, but I'm going to go ahead and get that brought down a good bit first. All right, we are coming together nicely. All of our adjusters here are adjusting pretty much effortlessly. I can tighten them up on the other side. The top part is pretty much done. This swings up and out of the way with no problem. So now I need to work on the clamp down here on the bottom. And let me show you what we got to deal with it on it. So down here on the bottom, there's this casting that basically kind of fits up underneath the web here and comes in and pulls up, and you tighten the bolt up that goes through this, and it just sandwiches it all together, and this just slides back and forth. So the problem that you can note here is that you see that this clamp is designed for the next version of this lathe that had a more narrow of a bed up underneath the bottom. We talked about that in the beginning, how this one here is about a 1/2 inch narrower. The width up underneath the bottom was even more than that. These clamps just don't work. So what I did is I actually modeled up and designed a new clamp in CAD. We made some patterns, had these sent off to the foundry, and had them cast. I needed these for the tailstock as well. This one here, you can see the slots where there was 2 bolts that go down through the tailstock. One of them in the foundry molds didn't have that hole all the way go through. The mold kind of caved in a little bit, and I told the guy at the foundry, don't worry about it, because I needed one with just a hole in the center, so it wasn't going to matter on this one. So he didn't worry about it. He just went ahead and sent me this one. I need to drill a hole down the middle, and we also need to go to the milling machine and just clean these up so that we got machine surfaces to slide in on there. And I need to figure out what that distance is and get all that worked out. But we're going to do that real quick, get this clamp ready to go, and we're just basically, we won't use the old clamp anymore. We'll go to these new clamps that will be the proper size for this particular lathe. So one thing to note on the original casting is notice how they kind of have these edges on 2 sides kind of beveled out. That's so that you can twist it in place down here. The original casting, when I put it in here, I couldn't get it to flip around. So I actually took that over to the belt sander and just kind of relieved 2 corners, and now I can get it to get down in here. That's bridging the gap. Let me note here on the bottom, there's a trough in here that is for the head of that screw to capture in. So let me get this back together here. So I think we've got this lined up now. Let me get this rod up through the bottom. And that'll lock it in place. There we go. And with that, we got our steady rest finished up. And with that, I think we have this steady rest ready to roll. This is going to be a huge help for me. I've had probably 6 times since I've got this lathe up and running that I kind of wish that I'd had this steady rest and it wasn't quite ready to go. And when this job that just came up, you know, I was sitting here debating on how I could get around not using the steady rest, and I did come up with a way I could do it, but at the end of the day I said, you know what, I just need to take the time and get this thing knocked out, because I know I'm going to need it again soon for something, and it's going to be nice to just have it ready to roll. At the end of the day, it wasn't that bad of a repair. I mean, it took me, you know, all in all, probably the better part of a day to get this thing fixed up and rolling. Did it actually over a couple of days, a little bit here and there, but you know, probably about a full day of shop time, and that's including shooting video, which always doubles the amount of time it takes me to do anything. But I think it's time and money well spent to be able to extend the capabilities of using this lathe. So there you go. With that, guys, that is a wrap. As always, thanks for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. As always, a big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships, all of which are great ways to kind of help support my channel or any other YouTube channel out there for that matter. If you feel like you're getting value from the content, consider chipping in a little bit extra, because it really does make a difference. And with that, guys, we will sign off. We'll get out of here. We'll catch you on the next video again. As always, thanks for watching.